Hello everyone. In a prior section, we began graphing quadratics by making a table and describing the transformations that occurred to it. We said things like it was stretched vertically, it was steeper, it was wider, it was opening upside down, it was moved up, it was moved down. Those were the types of words that we were using, and that's the type of results that we saw when we made tables in the prior sections. So we're going to start with a warm-up review question on that, and then we're going to move on to a different tool to graph quadratics for the more general cases. So to start, though, I'd like you to describe in words how the following three graphs would compare to the parent function. The parent function y equals x squared is shown right here to the right. So I'd like you to try by just describing in words. So you could do it just at the bottom of the most recent assignment. You could do it in the margins of the note packet. Start now, be a great tool for anyone that was gone, see what we were doing. And pause the video now for maybe a minute, unpause it after a minute, and everyone has had a chance to try, and then I'll go over it before moving on to today's topic. So pause video now, please. Okay, welcome back. Let's use Desmos to kind of show the results here. So you should have been using the words things like steeper, wider, moved up, moved down, opened upside down, all those types of things. And here's the results. So let's start with just the parent function. What was the first one I asked you about? Putting a negative out front. So if you put a negative out front, what's that going to do to the graph? It'll make it just open upside down. So you should have said that is opening upside down. Same steepness though. What about if you do 5 halves? 5 halves is the same as 2.5. So it's going to be steeper because it's multiplying by a bigger number. So you'd say it's stretched vertically, or you could say steeper. The last one, what if you add pi? Well, pi is just a number, 3.141592653 dot dot dot. Well, that's just going to move it up. It'll move it up by pi values. So all the points up 3.14 dot dot dot. So there you go. That's what we are working on in the prior sections. Now you need your note packet out to today. It should say something about graph x squared plus bx plus c, and our tool is going to be by factoring. So to start in the notes, you should see a picture like the following. And we're going to start by just picking out some features. And we're going to use those noticings as a tool going forward. My first question I ask you is, what is true about the y-coordinates of the x-intercept? So I'm giving you two different parabolas here just to show two examples that the feature still holds. Well, let's circle the x-intercepts. There's two of them because this is powers of 2, quadratics. So 2 here, 2 there. There's all, 4 of the x-intercepts. What's true about all of the y-coordinates? Well, here's the y-coordinate, here's a y-coordinate, there's a y-coordinate, there's a y-coordinate. You'll notice for all of them, all of the y-coordinates are equal to 0. That's important. If you are an x-intercept, your y has to equal 0. That's going to be super helpful. Now, notice where is the vertex located in relation to the two x-intercepts. And you might realize, hey, it's exactly halfway in between them. It's perfectly in the middle because parabolas are symmetric. So where's the vertex located in between the x-intercepts? It is exactly halfway between them. Using just those two clues, we can graph a large number of quadratics just by noticing that the x-intercepts are when y is equal to 0, and then once I have the x-intercepts, how do you find the vertex? You just need to find the point halfway in between. Those are the steps. So step 1 is going to be find the x-intercepts. Once I have the x-intercepts, I know the vertex has to be halfway between. If I have those 3 points, and turns out I know the y-intercept too, I have 4 points I can sketch the graph, and that's where we're headed. So our goal for this section is to graph quadratics in the form y equals x squared plus bx plus c, and we're going to do it by factoring. We're going to do it by finding the x-intercepts first. So step number 1 is to find the x-intercepts. How do I find the x-intercepts? We said a second ago, if you're an x-intercept, your y value is 0. So let's set y equal to 0, and then we're going to solve it. X squared minus 2x minus 8. How am I going to start to solve this? To factor it. So that's step 1 is factor. I need two numbers that are going to multiply to make negative 8 and add up to make negative 2. And those are going to be x minus 4 and x plus 2. So there's my factor. Now I'm going to use those to find the actual x-intercepts. You'll also hear x-intercepts called zeros. The reason that they're called zeros is because they are the x values that make y be 0. You'll also hear them called roots. You'll see they're called roots because they are the basis of the graph. They're where the graph starts, just like the roots of the tree. These are the roots of the graph. My two x-intercepts, or zeros, or roots, whatever you want to call them, are x equals 4 and x equals -2. So I'm going to plot those. 4 and -2 are my two x-intercepts. Now, where is the vertex located? The vertex, we said, once you have the x-intercepts, the vertex has to be halfway between them. Halfway between 4 and -2. How do I find halfway between? Well, you can count and guess and check. That's kind of a tough strategy, and it won't be great when the numbers aren't nice like decimals or fractions. So I need like more of a formula. Well, how do I find halfway between two numbers? I average them, actually. So the average of them is going to be where the vertex's x-coordinate is located. Right? We're talking about x location first. This is actually what we call the axis of symmetry, which is an x equals equation. So I'm going to write this by using V to stand for vertex, and I'm going to use a little subscript x because it's the vertex's x-coordinate. How do I find the vertex's x-coordinate? It has to be halfway between the two x-intercepts. Halfway between is the average. So 4 plus -2 divided by 2 is equal to -1. I know the vertex's x-coordinate. If I were to write this out, the vertex's x-coordinate is -1 comma something. So I know that the vertex's x-coordinate, oh, did I say -1? That shouldn't have been -1. That's my bad. 4 plus -2 is a positive 2. 2 divided by 2 is a 1. So it should be a positive 1. This is why you check. Right? Halfway between should be at positive 1. So I'm going to sketch in what we call the axis of symmetry here. X equals 1. It is actually not a part of the graph. It's just there as a reminder. It's kind of like the fold line. Well, if I have an x-coordinate, how do I find a y-coordinate? We've done this in tons of prior chapters. When we were solving systems of equations, if you know x, how do you find y? You put 1 in for x in the equation. So I'm going to put 1 in for x in the equation. That's going to be the vertex's y-coordinate will be equal to whatever comes out when I put 1 in the equation. So if I put 1 in here, I get 1 squared minus 2 times 1 minus 8. 1 squared is 1, minus 2 minus 8. If you type all that in, 1 minus 2 is -8, or sorry, 1 minus 2 is -1. -1 minus 8 is -9. So my vertex's x-coordinate is at 1, -9. So I'll do this actually like in green. 1, -9 will be right there. There's the vertex. That's where it's located. This step right here, you can actually do using a calculator. I'll show you how you can do that. So we found that the vertex's x-coordinate was equal to 1. So this is what we're going to do. I'm going to clear my screen. I type 1 and store it for x. Then I just type the equation in. The equation was x squared minus 2x minus 8. So once the calculator knows that 1 is x, or x is 1, x squared minus 2x subtract 8. Don't use the negative if you mean subtract. Use the subtraction symbol. There it is, -9. So you can use the calculator too to run that step. Last part is the y-intercept. The y-intercept, wherever this graph is going to cross, on the y-axis, if you're a y-intercept, your x-coordinate has to be 0. So I need to put 0 in for x in my equation in order to find the y-intercept. So 0 squared minus 2 times 0 minus 8. But you'll realize these parts will just go away. My y-intercept is going to be the point 0, -8. And that will always be true, actually. Going forward, you don't need to show this step I just did. It turns out that this value, oh, please stop it. There we go. This value right here is always going to be the y-intercept. And that was true for lines. Think about lines. Y equals mx plus b. This number all by itself at the end was your y-intercept. Now it's a c because there's 3 terms. This c value at the end is going to be your y-intercept. So your y-intercept is at -8. If there's a point right here that's on the graph, there has to be a mirror image right here. And now you get 5 points. With these 5 points, you can easily sketch the picture. It's going to look like that. And you're done. There's the process. We're going to practice this for a few days. you're going to first graph by factoring to get the x-intercepts is these two red points. Once you know the intercepts, you know the vertex is halfway in between. So you find the x-coordinate by averaging. You find the y-coordinate by putting that x-coordinate in for the x in the equation to find y. Once you have your vertex, you use your y-intercept and its reflection to get the other point, and you have 5 points. It's plenty of points to sketch in a parabola. So there is the first example. We're going to try another. Goal number 1 is to find the x-intercepts. Your x-intercepts are when y is equal to 0. So I have 0 equals x squared minus 1x minus 6. Now I need two numbers that multiply to make negative 6 and add up to be negative 1. Those two numbers are x minus 3, or negative 3 and plus 2. So your factors are x minus 3 and x plus 2. Now I'm going to use those to find the zeros, or the x-intercepts, in step 2. So my intercepts are x equals a positive 3, x equals a negative 2. So I plot those, negative 2, positive 3. Now I need to find halfway between, because that's where the vertex's x-coordinate is going to be located. The vertex's x-coordinate is always halfway between, which is the average. 3 plus negative 2 divided by 2. That's 1 divided by 2. That is 0.5. So I know my vertex has an x-coordinate of 0.5. Now I need to find the y-coordinate. Well, to find the y-coordinate, I'm going to put 0.5 in for x in my equation. I'm going to use the calculator to do this. So 0.5, store that for x. Hit enter. Now type in your equation. X squared subtract x subtract 6 tells me my y-coordinate is negative 6.25. Oh, I kind of ran out of room here. Negative 6.25. So vertex's y-coordinate is negative 6.25. So I know my axis of symmetry was at a half. So x equals 0.5 is halfway in between, but that's just the x-coordinate. The whole y-coordinate is negative 6.25, so right below it, right about there. That is where my vertex is. Last part is your y-intercept. Your y-intercept is 0, negative 6. So I plot 0, negative 6, its reflections right there, and then I sketch the whole picture in. Looks something like that. And then you're done. That is the process. Once you've done it a few times, they actually go pretty quick. You can probably do them in 1.5 minutes, 2 minutes max. So there we go. There are 2 examples. I'm going to ask you to try one. So zoom it out one more time in case you want to rewatch it and pause the video. Otherwise, I need you to pull out your whiteboard to try one for yourself from scratch. Use the last 2 that we did as examples to do this one for yourself. So pause the video now, maybe for 2 minutes. Find the x-intercepts, find the vertex, find the y-intercept and its reflection, and then sketch in the graph using those 5 points. So pause the video now, unpause it once you've had a chance, everyone's had a chance to try, 2 minutes, and maybe check and discuss with a neighbor. So pause the video now, please. Okay, I'm going to go through it real quick. This is what you should have got when you factor. You get x minus 2, x minus 4. So that means your x-intercepts are going to be at 2 and 4. So 2 and 4. Halfway in between them is going to be, obviously, you don't even need to do this average part. Halfway between 2 and 4 should be 3. If you average it, 6 divided by 2 is 3. So voila, you should have got the vertex's x-coordinate is going to be along the axis of symmetry. It always has to be, which is at 3. To get the y-coordinate, you put 3 into your equation. So you get 3 squared minus, what is that, 6 times 3? Plus 8. 3 squared is 9. 9 minus 18 is negative 9. Plus 1 is negative 1. So right there. So your whole vertex is going to be at 3, negative 1. And then your y-intercept is at positive 8. So 0, 8 up here. Mirror image would be right there. And then sketch it in. It should have looked like that when you did it for yourself. There you go. That's what you should have got. Okay, we're going to try kind of a special case one. but applying the exact same tools. So the first ones are kind of what I expect you to do, the core idea, what I like to call the meat and potatoes. This last part is kind of a special case one. The reason why is because you're going to factor not by doing the multiply add technique, you're going to be doing it by doing greatest common factor factoring. But the process is the same. We want to find the roots or the zeros or the x-intercepts first. That's when y is equal to 0. Only problem here is I don't have three things, so I can't do the multiply add. I have to do greatest common factor factoring. What two numbers or what number can I divide out from -2 and 4 that they have in common? Well, that's going to be a -2. What about the x squared and the x? I can divide out an x. So what's left behind? Well, -2 divided by -2 is a 1. X squared divided by x, there's an x left behind. 4 dividing out a -2 will leave me with a -2. X dividing out the x means there's no x's left behind. So when I factor it, it will look like this. If you need to, you should go back and review the lesson that we did on greatest common factor factoring to see what we did here. But otherwise, I'm going to assume that we're good. Now that it's factored, I can solve. When would this be 0? If x equaled 2. When would this be 0? It will be when x equals 0. A lot of people say it's +2, but nope, -2 times +2 makes -4 here. So that's not going to work. So your two x-intercepts are at 0 and 2. Your vertex is always halfway between. This one you can just see it. It's obviously going to be 1, but if you want to write it out, 0 plus 2 divided by 2 is 1. So your vertex has an x-coordinate of 1. To get the y-coordinate, you put 1 in for x in your, put 1 in for x in your equation. So -2 times 1 squared plus 4 times 1. That is going to be what, -2 plus 4, so that'd be 2. So your vertex is going to be at 1, 2, right there. And then the last part's your y-intercept. Hey, there's no number written at the end of this. It's because it's a 0. So it's 0, 0. It actually turns out when you have to do greatest common factor factoring, your x-intercept is also going to be your y-intercept. One of your x-intercepts is going to be the y-intercept. So this one, unfortunately, only gives us 3 points. But still not bad enough to sketch in the general graph, which is what we're doing, just drawing sketches, picking out key characteristics, and you'd be done. This one, like I said, you only get 3 points. You get the two x-intercepts and the vertex. The reason why is because your y-intercept is redundant with one of your x-intercepts. So you've got to be able to do a greatest common factor factoring one. Going to give you a chance to try one. I'll help you get started and then ask you to finish it out. This is one just like we did, so you can practice a special case one. This one, you would, same thing, you start asking when is y going to be equal to 0. This has a -1 x squared minus 4x. So there's only two terms, so you're doing greatest common factor factoring. You divide out the biggest number, in this case a -1. The most amount of x's you can divide out are single x. What's left behind? A +1 and an x. -4 divided by -1 leaves me with a +4. Now, I should be able to do the rest. So I'll leave you here to finish it out. Find the two x-intercepts. Find the vertex. You should notice that the y-intercept is already one of the x-intercepts, so you're only going to get 3 points, and then sketch the graph. So pause the video now for maybe a minute and a half to finish it out. Give everyone a chance to try and check with a neighbor and discuss, and then unpause it once you've had a chance to try. Okay, let's finish it out. Your two x-intercepts would be at -4 and 0. So 0, -4. Obviously, halfway between those is going to be -2. 0 plus -4 divided by 2 is -2, which is where your axis of symmetry is going to be. So your vertex is going to be at -2, comma. Well, if you put -2 in for x in your equation, let's use the calculator just to show one more time how to do that. -2, store it for x, then type your equation in. Our equation was -x squared, so -x squared, -x squared, subtract 4x. And it already knows the x coordinate is -2. Tell me it's +4. -2, +4. Right there. And then the last part is your y-intercept. You'll notice that there was no number at the end. It's because it's implied to be 0. So your y-intercept is 0, 0. Plot that right there. It's redundant with one of your x-intercepts. Then you sketch the graph in. I should have mentioned this on the last one. Hey, this one opens downward. You should have known that from the get-go because there's a negative out front. So negative out front, hey, negative out front, it's going to open downward. So there we go. That's it. You should be able to graph quadratics by factoring. Find the x-intercepts, halfway between is the vertex. Use the y-intercept and its reflection to get 5 points if you're doing multiply add factoring. Greatest common factor factoring, you're only going to end up with 3 points. But that is it. Thank you very much and have a good day.